And it looks like we're recording. I'll go ahead and share my screen. And Maria, I'll just show you really quickly. I'll go through this for everybody. And I'll also go through what we just did with David and others. Okay. So really quickly, there's several things we need to do just housekeeping-wise. First of all, if you go to 3.1 today on Wednesday, there's a Grasshopper graph file for you to download. That's the one that you'll be using for Project 3. It's a modified file of one of the demonstration files that Morphocode uploaded. So go ahead and download that if you haven't, and you can open that up in Grasshopper. Okay. Now, if you haven't gotten Rabbit to install correctly yet, then you won't be able to open up that file and have it do much for you. So let's talk about that just for a moment. I'm just going to go to my downloads folder here and pull it up so you guys can see it on my shared monitor here. Let's see, there it is, right over here, right? So it's when I downloaded when I went and downloaded Rabbit from Morphocode webpage, right? Give me this zip file. Mac, I'm on the Mac side, so the Mac always just like unzips it for me and puts it in a new folder. You might have to extract or unextract or whatever it is in Windows, but essentially in that side, that folder, there's two files, right? So this rabbit.gha, right? That's the file that you need to install in the right place. So when you open up Rhino and Grasshopper, you go to File and then go to Special Folders, Components folder, right? And it brings up and opens the directory inside your Windows C drive. It's under App Data, Roaming, Grasshopper. There's a set of libraries here for external plugins that third-party developers have put out for you to use. You just drag and drop the rabbit.gha into this one, right? You can see I already have, annoyingly, parakeet and rabbit and tree frog and ladybug and honeybee and lunchbox and human and Eddie and enchiladas and some other things, right? So Eddie's a fun one because that's with wind, circulation, and computational fluid dynamics. But anyway, you drag and drop that in, and then essentially you just have to close down Rhino and reopen Rhino and Grasshopper. Now, a few of you are having problems in that even when you do go through those steps, right, something's not working right. And so what happens is you need to go to this rabbit.gha file and right-click on it. And you see how a menu pops up, and down at the bottom there's properties as an option. Okay, I've just sort of let my cursor go to the properties part. You guys can see that. So if you've followed all the steps for installation, it's still not loading up as a tab here for you, Rabbit. Click on this .gha file, go to Properties, right-click, go to Properties. And some of you down here at the bottom in this box that pops up will have a longer you'll have a longer list of options here. But then down at the bottom, there should be a checkbox for you to unblock the file. What's happening is Windows sometimes will say, well, I don't know if if Maria or Joshua or Christian or David meant to actually download this file and let it start to run. So it looks a little suspicious. I'm going to block it until you unblock it. Okay. So you just have to tell Windows to unblock the file and hit apply and then OK. Okay. But that's where you find that. And then once you restart Rhino again, it should pop up just fine. Okay. Is anybody having problems with that?
So I should mark the unblock box?
Yeah. Yeah, you
okay.
click it to unblock it and then hit apply and OK. Now you have to restart Rhino. You don't have to restart Windows or anything, but you'll need to close down Rhino. Every time Rhino initializes, and then Grasshopper initializes, it goes through these components folders for the plugins, and then because the plugin manager automatically does this and does this every time the program initializes. Once you're successful, you'll have a Rabbit tab up here. So you have params, math sets, vector, curve, surface mesh. You might have some lunchbox tools or something like that. Kangaroo, maybe, I don't know. But I have Rabbit now, right? And so Rabbit, you'll have a set of tools that the Rabbit plugin extends Grasshopper to use. Okay. So that's how you know once it's worked. Jose said it's worked. Joanne got it to work. Julian got it to work, right? So I'm not sure why they didn't post that right up front on their website, but that's how to take care of that. Sometimes that happens on the Windows side of things. It's been a long time since I've
Now it
actually used
works.
Windows.
Thank you.
Yay, success. All right. So again, just as a reminder, the file that you're going to use and that we're going to talk through today and do together is right here. Sorry, you guys can see hopefully Chrome, right? Canvas. I have it pulled up for 3.1 for Wednesday. There's a link here. They'll take you to Google Drive. You can download my Grasshopper graph file, and you can open that up in Grasshopper, and it'll look something like this. It's a big, huge file. This is one of the, this started as one of the example files that Morphocode gives showing how the cellular automata works. And so it's, you know, it's branded as such, and it has their labels and some of the comments and things like that that they have inside, okay? So we're gonna do, first of all, I want everybody to sort of quickly pay attention to my screen. We're just gonna go through a few of the highlights to sort of understand conceptually what's going on here based off of the, what we talked about yesterday, or let's say Monday, and then look at this particular cellular automaton system, okay? This particular CA or cellular automaton is based on Conway's rule of life, game of life. And so I just want to sort of briefly go through this, all right? It's telling me file type is not supported. You're not don't double click on the file. You have to follow the instructions. You drag and drop the file in the right directory. You don't double click on anything. You don't try to open the file. Rhino and Grasshopper will do that automatically. If you go to the Morphocode webpage, it'll tell you exactly what the instructions are. Like it's just again, you go to File, in Grasshopper you go to File, Special Folders, Components folder. That opens up a new directory, and you drag and drop that GHA file into here, okay? That's all you have to do to install it. Everything else Rhino does for you. Okay, just gotta put it in the right place. All right. So if you're still having problems with that, then we'll have to save it towards the end here. I'll try to keep as much time towards the end, but we got to keep moving. Because not only am I going to talk through this really quickly with you guys, but then we're going to try it step by step together. Okay, so anyway. Here we go. This is a big tingle bowl of spaghetti, but there are some key highlights here that I want to sort of talk about. First and foremost, I'm going to go ahead and, again, just pay attention to my screen for the moment. This is the exact same file you guys have back at home. So I just want to pull these things together so you can see both the Grasshopper and the Rhino preview at the same time. Let's just do that. Okay. And I'm just going to turn off the stupid grid. Did I mention it's stupid and I hate it? Yeah, there we go. Get rid of that thing. There's no business being on my screen. It's just gross looking. All right. So what you'll notice is that there's several things going on here. First of all, we're making a grid. Okay, that's just a grid widget. You can see it highlights green. And this is going to be basically the size of your portion of this sort of urban fabric that you're going to grow. Okay. Just like Conway's Game of Life, this is broken up into cells, right? Each cell can be alive or dead, right? On or off. And so what we do to populate each one as alive is we place a point inside of it. And so you can see that these points start here, and then they begin to grow upwards in Z, all right? You can, again, make a set of points in Rhino, and then we'll basically reference them into Grasshopper with one of these point widgets, and then we'll plug those in. Then over here, what you'll see is a manual time control. Yours might be set up to something like 40 or something super tall. But essentially, this is the clock. So these are the sort of the keyframes or the ticks, right, for each generation. So let's say this is our initial seed condition, right? Like all of the X's signify a cell that's live, right? Then we can turn it to 1, right? You can see the next generation based off of playing out the rule. So you have more than 3 cells, adjacent cells, then it's overpopulated and something will die. If you have fewer than 2 cells, something will be underpopulated and something will die. If you have just the right conditions, things either continue or even cells become alive through reproduction. Okay. Each time generation is then just stacked on top in Z. So if you look at this, this is basically just a stack of each generation, right? Stacked on top of each other, right? And so it's not like the first generation disappears. It's at Z equals 0. The second generation is Z equals 9. The third generation is Z equals 18, or whatever it is, whatever that height increment is. Okay. And so essentially, we start with a C condition, then we let it play out n number of times with this slider. And we can adjust that slider and play it out for as many generations as we like. In fact, we could even change the maximum of that. I wouldn't go too much taller. I mean, you can see at some point, we even start to generate some things that grow out of nowhere. That's pretty interesting. But we'd probably, after we bake this in, is probably delete some of those things out since they defy gravity and physical rules of nature. All right. That's playing it out to 100 generations. I'll play it a little safer and maybe go down to something like 40. All right. You can see here that what I've done is I've actually made the height generator something that you can play with as a multiplier. So you can begin to increase the height, the spacing between each generation vertically right here. Down here, right, I can basically reference the unit. So what we've done is we've made a set of points in space. But now what we can do, and I'll just make a generic block for the time being, right? I'm just going to make a generic block. I'll say first corner of this cube is going to be 0, 0, 0. And the other corner is going to be 9, 9, 0. Because that's the size of our grid, 9 by 9. And I'll give it a height of 9. So I'll just use the standard cube of our existing grid. I'm just going to right click on this widget once a brep. So I'll say set 1 brep. And it's going to disappear. Let me select something from Rhino here. Yeah, I'll select that. And now what it's going to do is it's going to look at this item, and it's going to go from 0, 0, 0 to each of these points and make a copy. Ah, success. All right, and so now we have this sort of rather sort of cellular cascading set of blocks in 3-dimensional space here, right? Each of those points is populated with one of my units, right? In this case, just a generic block. Let's see if I can get that Grasshopper window. Sometimes Grasshopper disappears after it's done a lot of computation. If you just minimize Rhino and pop it back up, then it brings up both windows again. I don't know why it does that. I suspect, I don't know if it does it on Windows or if it's just my version of Windows on Parallel. Parallels doesn't handle OpenGL so well, which is annoying. But if you're running either a PC or if you're running a MacBook Pro, but then you have a Mac running through Boot Camp, then suddenly you can actually upgrade OpenGL to the version you need to for the best results. Anyway, what ensues now is a big tangle of stuff that I've given you guys as tools to begin to randomize some things here. So, for instance, you can begin to throw in a random rotation angle, or to jitter the elevation in certain ways. And so you can begin to experiment with, and I do this, I should probably not try to drag a slider. Let's see what happens here when I just sort of screw around here. Just thinking hard. Okay, didn't really do much there. Let's see. This is a random rotate. Ah, this is a standard rotate. Interesting. So if I plug that in for an angle, let's see what happens. No, this could be a disaster, right? Does it look like it worked? Oh, yes. Now if I go in, you can see that there's a set of each one's been rotated in some sort of random angle, right? So you can begin to play around with the stuff that I give you. Here, I think it's constrained to within 45 or 90 degrees of rotation, but still random. So that with a standard cube, you won't notice if something's rotated 90 degrees or 270 degrees or something. But if you have something that's not completely symmetrical on all sides, then suddenly you can get some rotation. Okay. All right. Now, I'm going to go back to the very beginning, and one of the things you'll notice is that it's basically just taking all of the cells and it's randomly reducing the cells that are actually going to be populated with a random seed generator. Okay. So what we're going to do, step by step, is we're going to start here at the very left, down at the left bottom, and we're going to, first of all, let's see, I'm going to I'm going to do several things. First of all, I'm going to go ahead and clear this out. So actually, let me just open this file again so I have exactly what you guys have in front of you. That would help if you're going to follow along step by step, right? Okay, so here we are. Okay. I'm going to come to right here. You see how there's this, I think that's the move widget, right? So it's about halfway through. You can see it over here. It's the one highlighted green. You can see this sort of group selection box, right? It's right over here towards the right-hand side of that. When I click on it, you see all these points turn green. I'm going to right-click on that, and I'm just going to turn the preview off. Okay. Just right-click, and then the box that pulls up, you can turn off the preview. You can toggle that off. Now all of those vertical points will go away for the time being. Okay. Which I think is important. Right. I can always turn that preview back on. Okay. I'm also going to, well, you know what? Sorry. What I just told you, go ahead and toggle that back on for preview. My apologies. I wasn't thinking a step ahead here. Sorry. Go ahead and turn that back on. Right click and turn preview on. Sorry about that. Go to this time, this number slider, which is our sort of time ticker, and I would roll that back to 0. There we go. That'll work. Okay, that's better. So now you only see these initial seed points, which I think they highlight green right here. Yeah, they sure do. Okay. I'm just going to turn off the preview for all of these point widgets. You'll see that there's one that has nothing referenced in. It's this orange widget down here that's a point widget. Okay. And that's what we're going to do. We're going to reference these in. Okay. So now here's what I will have you turn off with the preview. Okay. Again, just roll back the time slider, the manual time control to 0. So we're back at just generation 1. Okay. This point widget right here that's in between the grid, this random reduce, this grid icon, and then this green icon with the dot that's being pushed like a button. Okay, this points widget that's highlighted green, I'm going to go ahead and right click and turn the preview off. Hopefully. I'll do the same thing here. Not sure why these are still showing. Oh, okay. Well, whatever. But what you need to do, and I'm just going to go to top view for this, right? You need to leave Grasshopper open so you can see the grid. But now with your point tool in Rhino, you're going to make a physical set of points. And they don't have to be exactly in the center of these, of each cell. But for each cell that I want to be alive, I'm going to physically make a point, right? So I use the point command here on the toolbar. And then I make a point. I just click with my left hand. I can right mouse click to repeat the last command and then click again to create another point. What I'm going to do is I'm just going to start to make the initial seed condition. Again, remember, if I turn all of these on, right, like let's say I populated each cell with a point, what would happen? Literally almost everything would die from overpopulation in the second generation, right? So you're always trying to strike a balance between too crowded or overpopulation, and too sparse or underpopulation. Okay. I'm just going to start to make some clusters where you start to see several at a time, but there's always sort of space in between to let some growth happen here. All right, so I've populated just a little portion of my grid here, right? Just about, maybe 1/3 of the grid. All right, I'm gonna go ahead and test this out. I'm gonna go back to Grasshopper, and you see this point widget. I'm gonna say set multiple points, right click on it and say set multiple points. I'm just gonna click and drag and select all the points that I made in Rhino, and right click to accept. All right, and now I'm gonna plug this in to this green button icon here. See where I'm plugging it in? Huh? So I'm going to bypass this, and I'm just going to plug in this new set of points. All right. Don't worry, I can repeat this for you in just a minute. But now, when I go back to my time slider, I can see this play out, generation by generation, vertically. Right? Some of these actually start to grow exponentially. Look at this. Some of this is growing outwards and branching in different ways, which is pretty interesting. It's an interesting way to think about urban fabric. If you have all these little footprints, but then after a while, the buildings start to merge and grow together. It's kind of an interesting sort of shared airspace sort of thing, right? Maybe that helps with lateral loads, right? Like, because the problem with big, tall buildings is that you have to put dampers in them to sort of counter the sway from wind, lateral loads like wind and earthquakes. So maybe if they start as different plots, right? And you can still maintain streets in between them. Yeah, right. And then they start to actually, that'd be kind of interesting. Anyway, you can always think about like the sort of value proposition here, right? All right. So look, this could have been an unmitigated disaster. Some of these could easily die. In fact, you can see some instances where due to underpopulation, right, this thing only goes up one more story and then dies, right? Same thing here, right? So I can always wind this back. Okay. I can go back to Rhino space, right? Go back to top view. And I could say, that's fine. Maybe I just want some short 1 or 2 story buildings here. Or maybe I just try to add a few more in a couple places. Just use that feedback loop, right? Or I see the patterns that actually produce some more interesting results and I replicate them elsewhere, right? Let's say I have a 4, like a T sort of configuration. That seemed to do some interesting things. Maybe I start to put some T's in different orientations here. Again, I'm not exactly sure what's going to come out. I provide the initial conditions and then I let time do the rest, right? This sort of fantasy, quick moving evolution game, right? Conway's Game of Life. Survival of the fittest, just based off of the population, how many neighbors are around it, right? Essentially. Let's try a couple of these. Sorry, for some reason, I don't know if you guys can hear it, but I hear a jackhammer outside. They're still building houses behind me, and so it's like a construction zone. Every couple of months, I have to, get my tires patched because I've run over a nail just driving through the neighborhood. Still trying to figure out if I can sue people for that. Probably not. Oh well. All right. And so as I begin to add dots, again, I want to come back to this widget. This widget contains my collection of points, right? If I select it, it turns green. You can see the points that I've already created. Also, preview in Grasshopper or in Rhino is green. What I can do is I can say clear values, right click. I'm just right clicking each time and saying clear values. And then I can go ahead and right click again and say set multiple points again. And then select everything that I've done once more, right click to enter, right? I'll go back to perspective view so I can sort of see in Z what's going on here. See how this thing grows again. Okay. Yeah, look at that. Wow, that's pretty bizarre. Interestingly, there's some patterns that begin to just give some homeostasis to, right? Like, so these are predictably going to repeat forever. as long as I go, right? They just happen to be so evenly spaced that they stay that way, right? Like they just have the right conditions to not spawn any new points and to not die, right? You'll also see sometimes if you have like just 3 in a row, they'll alternate almost like a cruciform back and forth, right? And so you'll begin to understand, yeah, there's one right here, right, in fact, right? So it's 3 this way, 3 that way, 3 this way, 3 that way, 3 this way, 3 that way, as it continues to grow upwards. This one as well, it looks like, maybe, no, maybe not. Some of them are much, much harder to determine. I don't know why this has grown over here, but I suspect it's this part gone over into the grid and appearing over here. It's pretty bizarre, isn't it? Right, and so again, the fun part of this is that you don't exactly know what you're going to get out. Okay, so you have a set of rules, you have a set of ingredients. These rules are simple and the ingredients should be simple, but the complexity builds, right, as this thing starts to, in a non-determinate way, begins to play out in real time over time. Okay, and of course you can control, you're the timekeeper, you can control how many generations this moves. Okay? So again, back at your computer, right? What I've done, right? Again, this was started as orange because there were no values here, right? This point widget down at the bottom left, okay? And what I did is I plugged it in to this widget. I set my timer back to 0, right? Okay. And then in Rhino, in top view, I can populate a cell with a point, right? I'll go ahead and start doing that here again. Why not? Just continue. Again, this might be overpopulated, right? This one has, this cell, for instance, this one right here, has 1, 2, 3, 4, 5 populated cells around it. So this one's going to die the next one, right? But I'm always sort of trying to think about, well, what happens then once that dies, then suddenly maybe the conditions are right for it to pop in again, and then to pop out, and to pop in and pop out. So again, you can start to see maybe some patterns here arise as you do this. What's interesting, as long as the point is inside the cell, it doesn't matter if it's centered. It has a sort of test for understanding which cell the point is inside of, already built in here to the plugin. That's what makes this plugin so useful, is that all of the sort of detailed debugging has been done for you. So it's a little more intuitive now to sort of grow your own stuff here, like a petri dish, right? This is like putting in some bread yeast into the petri dish, and then you come back 3 days later to see what you have inside, right? How tall it's grown and how green and fuzzy it is. Yeah, so sometimes I had that happen here. Let me just show you, Josh. Sometimes things pop up. And think about it as like weather, right? Sometimes the conditions are just right where there wasn't a point, suddenly something generates. But oftentimes what you'll see is if you look at the other opposite side of the grid, you'll see that what's growing on that side is actually going off the grid and then reappearing on the other side of the grid, okay? It's kind of like, here, let me just clear values and I'll show you. I'll go ahead and set multiple points here. Go ahead and bring all these in. So I added more points. I'll just go ahead and do that. Go back to my perspective view. All right, look at that. And so what we're doing is we're generating the seed points, right? Let me see what I have here. See how this just, on my screen, on the right-hand side, this just pops up out of nowhere, like, I don't know, 30 stories in the air. If I go over to this side, you can see it's actually just a continuation of what's happened as this goes off the grid. It actually appears over here. Weird, eh? All right. Same thing here. This is just where this part continued to grow and got cropped over on this side of the grid. And so it reappears over here. Okay. So we'll talk about that in just a bit, because when we bake the results in, we'll have to look at those sorts of things and see where we need to fix. We either delete those stray things that appear to defy gravity, or if we like them enough, we can select them and then just pull them back down to the ground, just move by moving them or something. Okay. But for now, just look at the results, right? I'm starting to get some stuff. All right, looky there. And again, it's all based off of, what happens up here is all based off of the pattern of points that I'm creating at the very beginning. Have I stressed that enough? All right, so let's pause for a moment and let you guys click around. Anybody has some questions? I see a question from Eric. Eric has a question. Eric, what's your question? Shoot.
I'm sorry if I might have missed this. I don't know. So the extruded rectangle we uploaded, the little cube, we set that as the surface, and then it follows the points that we lay out, right? So I'm wondering, does it matter what sort of surface we choose? I don't know if you said that, but I was just wondering if, like, let's say I wanted to set like a ramp piece, like a triangular prism or something like that.
Right. We'll get to that in just a minute.
Okay.
That's the next step. But yeah, essentially, it's the unit that we're going to aggregate.
Okay. Thank you.
So what we're doing is we're creating the aggregation locations, right, with all these points, just as you mentioned. So this gets to this is a nice segue, actually, Eric. So I'm glad you brought this up. So what we're doing first and foremost is playing around with the actual system here, right? And so what the system generates, that's something to be experimented with, where you start with the ingredients, in this case, the initial points on the grid, right? Which grids are alive and which ones are dead. Then you let it play out. We get something three-dimensional over time. The next step, right? And that's as soon as we make sure no one has problems or any more questions, is that we define this unit. This is I recommend nobody just use this dumb block that I've made here. Okay, that was just as a sort of example, and I don't want to take a cool-looking example from you guys. But that's the example I just wanted to quickly show. Right, it's just a cube. But essentially, that's the other ingredient you can experiment with, right? Okay, so what's the sort of spatial massing unit or module that you plug in here that then gets aggregated into a larger cluster? Okay, can you explain what things we turned off the previews? Mine looks a little different. Yes, thank you, Jasmine. That's a great question as well. I'm going to go back into Grasshopper, and I'm just going to expand this out a bit. Okay, I'm just going to zoom out a little bit. I'm really primarily working in the left part of this graph right now. So what I did is I turned the preview off for these two widgets, but essentially I just bypassed them with this widget. This is the widget that started as orange. And so I just plugged this in here, but I turned the preview off here. So I went ahead and this one and this one. Can you see the two widgets that are green? I right-clicked on both of those individually and turn the preview off. And the menu that pops up, you can turn off the preview. Okay. The other thing I did, just a little further over, you can see how these things flow to the right. This manual time control slider, I turned back to 0. Okay. I think that's really all you need to do. Okay. Again, I'll highlight those green while I field any more questions in case you're trying to follow along. Hopefully you can see those, right? So this is where our points plug in. You can see this where we make the initial grid. Here's how we spawn like which points are on and which points are off, which grid cells are on and off. Okay. It's these two right here. I've turned off. I didn't want to see them anymore. Forget about them. Okay. Any other questions before we basically move on to what Eric was asking about? All right. So I'm going to play these out to, maybe 30 some 40 generations, whatever. I think it's set arbitrarily at 37 for me at the moment. Maybe I'll play it out to 40. All right. Again, in order to make this thing grow, it's just basically a function of the slider. So each generation, right? Now I've played it out to 41 generations because I've gone from 0 to 40. All right. If you move a little further, down here in this green box, or sorry, purple box, right? Where I've grouped this, use this to reference your unit, right? This is little brep widget, right? Just like our point widgets, where we can right click and reference some points in from Rhino into Grasshopper. This is made to select and reference in a polysurface from Rhino into Grasshopper, okay? And so this is what I right clicked and said set one brep and selected my cube, for instance, right? All right, and so this cube becomes my unit to aggregate. And then you can see once you populate each of those points as a centroid with a box, right, what happens. Okay. Sorry, I don't know if you guys can, the jackhammer is actually ridiculously loud. I don't know why what they're doing out there. It's stupid. Like half the time, it's like a new neighborhood. So they're like, I don't know why they decided to pour the curbs for the sidewalks and roads, and then 3 months later come back and like repave all of the curbs. I don't get it, but whatever. Anyway, so it has something to do with maybe their bonding running out or something. It beats me. All right. Yeah. like, I mean, correct me if I'm wrong, but I don't remember too many cold days during the summer, so I don't think they let the concrete freeze or something. So I don't know what the crap why they think they have to blow some of this stuff out and re-pour it, but whatever. For the sidewalks, I don't get it. And it's not even my neighborhood; it's like the one adjacent. Like what the heck? Anyway, all right. Okay, all right. So with this unit, you know, this is a big decision you have to make, and you can actually experiment with those. Okay. Again, just for reference, I'll bring up. I'll go back to Canvas here and bring up some of the examples from last year. I think a lot of people had some fun sort of trying to come up with some weird things, right? So this was a unit that I used. And then I actually, you know, I started playing around with random mutations with rotation, random mutations with height and jittering their X, Y, and Z coordinates, right? Which you can do over here. You'll see that there's some random jitter, or sort of introducing some randomness to these X, Y, and Z values for these points in order to sort of make things not quite conform to the grid. If I zoom in on some of these, right, you can see some of them went pretty simple. Some of them went with like a frame or a cube with holes punched out of it. Some folks went with like sort of what looks like L or Z looking sort of blocks. This one's fun. This one like started out with like asterisk, sort of like a radial sort of geometry, and then suddenly it looks like you know, the old game of jacks, you know, like those little metal asterisks. It looks like they just got like 5,000 of those and just piled them up and saw it, you know, what emerged or something, right? So you can begin to play around. What's also interesting, and we'll talk about this on Monday, is they added blocks and curbs, okay? And so what's interesting is that they actually added some, like, let's say, normal looking buildings as just extrusions in Rhino, so that it made these things sort of look like they were sort of growing between, on top of, through, and stuff like that. It's sort of, you know, like you have the sort of regular host geometry, and then you have the sort of parasitic growth geometry. It's kind of a weird thing here, but they really got into this. It was kind of fun, actually. Let me talk just a minute or two about this grid for a moment, okay? I think this is also really important. And I will write this out in Canvas for you as well as posting a quick diagram. Okay. But first thing I would do in Rhino, and you can always do this. First of all, you can always save your Grasshopper file and open this back up, and you can still get the same exact results if you still have, you know, these points somewhere, right? But one of the things I would recommend you do is go to Tools in Rhino, go to Tools and Options. Right, Tools, Options, and go to the units, you know, in this box that pops up. Make sure that your units are set to feet. Okay. Let me repeat that. If you go to the Tools pull-down menu in Rhino, go to Options. These are where all the options are in Rhino, on the Windows side anyway. And so this brings up a number of options on the left-hand side. Units is one of them, and then when you click on units, you can begin to adjust these things, like let's say which units we're using, but also like the tolerance, both in angles and for distance. You can also, you know, play around with other things. Set things to feet. What you'll notice over here is that this should be standard, right? Because I gave it to you this way. The dimensions over here is a 9-foot by 9-foot grid that extends in 50 cells in one direction and 43 cells in the other direction, right? So essentially, this sample of urban fabric for you guys is 50 times 9 feet. That would be 450 feet by 387 feet, okay? Let's just test this out. Can I snap to something that's actually not in Grasshopper? No, of course not. I could always bake this grid in. I'll just bake this in. Oh, sorry, it's still thinking I wanted to mention things. Okay, for my purposes, really quickly, I'm just going to bake this in. Bake. Because I want you to see this on the recording and just in person here. Okay. I'll just go ahead and turn off Grasshopper for a moment. Now you can see each of these cells is actually a closed polyline square, right? Okay. But just to show you guys, I'll just go ahead and dimension. Oop. Let me turn on my object snaps. Here we go. Oh, snap. All right. 387 feet. Yeah, that checks out. Right? And this other one should then be 450 feet. Okay. Maybe I didn't actually snap to the right thing here. There we go. End. So you're pretty sure I know how to do basic multiplication right now. Yeah, 450 feet. I must have been snapping the wrong thing somewhere. All right. So I will post a diagram of this for you guys on Canvas right after class. In fact, I'm basically making this diagram right now. But what I'm going to ask you to do is to divide the 450 dimension up. What you're going to do is you're going to draw 210 feet of block, like city block, and then 30 feet of street, and then 210 feet of city block. And then the shorter direction, for 387-foot direction, you're going to draw 109 feet of block, 30 feet of street, 109 feet of block, 30 feet of street, 109 feet of block. So that's not the most intuitive set of dimensions. So let me just go ahead and do this right now, and then I'll post this as a diagram for you guys as well. Okay. But what I'm getting at is that this will actually be inside those blocks is where you'll actually be populating cells, and that you won't be populating cells that are in the streets. And then what we can do is we can actually close those polylines that you draw off the blocks, extrude them just like a little bit, so they actually look like they're curved up from the streets. And then that actually helps with the illusion of this being a sort of part of a cityscape. Okay, so let me just do that really quickly. What I'm going to do is I'm just going to start here. I'm just going to draw from this corner 210 feet. Oh, why is it doing that? There we go. And then this direction, let me turn off my object snaps and leave my ortho on. I'll draw a 109-foot line or segment. What I'm doing is I'm just drawing a polyline. There's 109. I'll go back this way now, 210. And then I'll just click this to close it up, right? So that's one block, okay? This again is in the long direction here. I'll dimension this clearly and post this as a drawing on Canvas for you guys. So, you know, if you're like, wait, what were those dimensions again? Don't worry about it. You'll see them, and they'll be there as reference. So I can't change them on you or anything. 210 again, this direction. 109. Let's see, 109. There we are. I don't want to snap to a center. 210. Then close that up. All right. This should be a 30-foot street, a 30-foot space. Let me just, let's see. Just confirm. Oh, sorry, snap to. Why is center on? Why do I have that as a, yeah. All right, there we go, end to end. Yeah, 30 feet, great. All right. Streets are gonna be 30 feet as the sort of right of way. This is 109 in this direction. So what I can basically do is I can basically just copy both of these over, just snap them to the edge over here. Oh yeah, there we are. I don't like doing extra work. I'm lazy when it all comes down to it. And now I just need to move these and make it the center blocks. So this is 109 feet. I need to move it 109 plus 30, so 139. So I'll just move it 139 feet. There. Yay. Oops, sorry, I just undid. Okay, there we go. All right, so here we have those, right? All right, now what I'm gonna do is I'm gonna select these. Really carefully, just make sure I select just those, right? I'm going to, I know what I'm gonna do. I'm gonna extrude them. Extrude them, solid, yes, downwards. So I'm not sure why. Let's see. Select curves to extrude. Sorry, gotta select these, I guess, again. That's annoying. But I had them selected already. Whatever. Thanks a lot, Rhino. Just kidding. Solid, yes. Why is it not extruding? That's weird. Select path, curve, near start. What does that mean? Am I just like doing the wrong? Oh, sorry, that was extrude along curve. Okay, I've selected the wrong. Okay, sorry. Man, it's one of those days sometimes. Sometimes I wonder, like, my head wasn't attached if I leave it at home or something. I don't know. Solid, yes. Okay, for those of you who had me in studio, you know what I'm talking about. Like Josh, sometimes you're so absent-minded, it's just silly. So I'll just, I'll extrude these down, let's say 6 inches. We're dealing in units of feet, so I can just say 0.5, because half of a foot, right? I'll just extrude them downwards. There, yay. And then last but not least, I'm just gonna make the planar surface here for the sort of ground and street. I'm just going to snap from, let's say, this corner, make a planar surface. From this corner, I'll just snap down there at the bottom of these blocks, not the top of the blocks, but the bottom. And I'll snap, I'll go all the way over here to the alternating, the other corner, maybe. Oh, come on, good grief. There we go. Just zoom around here, make sure I snap there. Oh yeah, look at that. Isn't that good? Right, now, I'm going to, of course, get rid of these points that are over here, not inside one of my blocks. I don't want a bunch of points out in the street. That would just be silly, you know. I say that, and then you guys are like, silly, huh? I'm confused by what we've been doing already. Anyway, but yeah, just sort of move some of these points over here. Oh yeah, just keep them inside the block. There we are.
Josh, are you joining the curves before you extrude them?
No, I just drew them as polylines, so they were already joined.
Okay. Okay.
Right. Okay. All right. And so I will post this with some actual readable dimensions for you guys within the next half an hour after class. Okay, and post those on Canvas. All right. It's not even important that you extrude these things right now, but to get those shapes in so that you can make sure your points are within the blocks, I think is really important. Okay. So I'm going to move these points around, and of course I can always go back through and I don't know, for some reason Grasshopper, oh, it's because I moved the points, but I didn't set the manual control back to 0. Oh, that's funny. Anyway, all right, so on and so forth. Okay, I'm going to move those points around until they're actually contained inside the blocks. All right. Once I have something, right, again, play around with these things. Don't make these things too, make sure that the thing that you use here can actually be all joined together as just one polysurface, one VREP, okay? You know, you can always think about, you know, joining some stuff together. You also have these Boolean tools, right? So what those Boolean tools do, for instance, let me just clear this values out. Yeah, if you want, I would say do the streets and sidewalks before you place the points, so you don't have to move the points. Yeah, that's yeah, absolutely. You know, that's a good point, Jasmine. You can tell again, I'm just sort of totally absent-minded here. I'm just going to move this out of the way for a moment so you can see what I'm referring to. Let's say I made a copy of this box and move it out here just slightly. I'll just go ahead and just continue to move this copy in X, Y, and Z here like this, right? I can subtract one from the other or join them, like do the Boolean union, Boolean difference, or the Boolean intersection, right? So Boolean difference, I could subtract this from that. Oops, sorry, hold on. Right? So you could subtract a solid from another solid. Or you could like basically join these together, right? You could do a Boolean union. As you can see inside, I have a bunch of self-intersecting stuff. Let's see. Maybe you can see, ghosted, right? So you can see that these things actually intersect each other. If I want to trim all that stuff out and make it all joined into one just solid, I can just do Boolean union and do that, right? Now suddenly everything's trimmed on the inside. So, you know, this is just one big joined polysurface, right? So you could begin to have fun with making a sort of unit that, don't get too complicated with the units, but I wouldn't just do a cube. Okay, that's my only point. And again, I'm talking about just that one unit that you make that gets repeated over and over again at each of these points that we generate with the cellular automaton. Okay. Again, just for reference, a number of, oh wait, where did Canvas go? Oh, sorry, I just minimized it, right? Let's see if I can zoom in on some of these, right? You can see there's a variety of these units that people made, right? And some of them are orthogonal and some aren't, okay? Some of them start orthogonal, but then they get rotated, right? Some of them start flat, and then you just add more generations to them. Some of them are quite porous, actually. Okay. You can see some larger examples here. Right. Again, you can see some of the results. Actually, these are pretty low res. Okay, got it. All right. You stay that I would say it's 9 by 9 by 9-ish. They can be a little smaller or a little larger. I would say, if anything, go a little larger, because then, again, the key to this is aggregation. So if you start to look at these things as these sort of piled up aggregates, right? And here's an example I would say to maybe look at. Herzog, Demuron. You guys know who Herzog and Demuron are? Swiss architects, really good. Some of the best architects in at Rise, New York, in the universe. But you can always look at, for instance, they have this one, 56 Leonard Street, right? And it's kind of quite an interesting sort of way of sort of thinking about how massing can change, right? The form of the building can be articulated, right? And so, you theoretically, you're not that far away from sort of articulating these as windows, floors, slabs, walls, and things like that. Okay. Anyway. The other thing I would say is you can begin to play around with this, but do it sparingly, right? Like, you can begin to add some rotation to these things if you'd like, right? On Monday, we're going to check in on the results that you guys have generated. Do some troubleshooting to start off with. No doubt that we'll have to do that, okay? And we'll talk a little more about customizing, but then we'll talk about the baking and making 2D and some of the rendering and that kind of stuff. So we'll start to work towards getting these things formatted. And then the following the Wednesday after Monday, so a week from today, we'll talk about the perspectives and some Photoshop as well. So we'll overlay Photoshop into this. All right. All right. So again, happy growing. But again, what's interesting about this, I would say is, this is kind of shifting gears in that I know you guys are busy right now, but we still have to have class. And so, exposing you to the sort of advanced digital media side of things, I would say this is sort of pointing towards where we might be 10 to 15 years out from now, where you are sort of generating, or you sort of make generative algorithms, or you start to use generative algorithms to actually begin to generate some of these things, and rather than just having to sort of manually draw it out from your head, right? So this idea of, where this is going, right? Computation has sort of allowed us to sort of understand some natural systems, generative systems, in ways that we couldn't before, right? But now we're starting to sort of understand how they can actually be useful to generate our own thing. So you can imagine now, some of these parameters actually being tied to, let's say, some of the material constraints, right? Let's say the size of the materials that we can get, the step over between how far things can deviate off the grid related to, let's say, the orientation, solar orientation, right? So maybe when you have something above something else, a unit sort of project outwards, it becomes self-shading for the unit below, right? Those sorts of things. You could actually begin to make a generative algorithm that's actually quite smart and can actually begin to generate lots of different, an enormous number of solutions that are fit, let's say, based off the criteria that you give it, right? So again, the idea of being able to generate or leverage maybe the generative capacity of computational tools is important. It's not just about doing the things that we could always do with the pencil, right? That's boring, right? We could still do those with pencil, right? But then to begin to sort of look at what computers are actually able to do and what they're actually really good at. In particular, we set up the conditions, the ingredients, the parameters, and then we can let the algorithm actually create the sort of complex part-to-whole relationships of larger aggregations, massings. Again, the idea here being that if you can actually incorporate some of those design constraints that are really important to you, then they can actually become generative design constraints for you, right? And so you can actually begin to let the computer generate all kinds of different scenarios that you would have probably not even thought of, that can actually begin to solve some of the design problems that you were were wrestling with in your head. Okay. The reason I say this is because, you know, evolutionary solvers have been out there for a long time, but I've now even noticed that Autodesk must have bought one and incorporated it into, and it shows the most banal example where it shows like the sort of footprint of an apartment building and how to maximize the number of units on the site based off of also the number of parking spaces required versus code. So, you know, those two competing constraints, like maximizing the number of but think about that. That's an interesting problem, right? Maximizing the number of units you can get on a site, but also making sure that you have the number of parking spaces you need by code for each one. So the more units you get, the more parking spaces you need. And so those two constraints are competing against each other. Trying to find the sweet spot can actually be kind of a tricky proposition. The computer could actually help you with in understanding what the 3 or 4 base configurations might be in order to maximize, let's say, a developer's return on investment or something like that, right? So again, computational tools they're getting quite sophisticated in that they're there to actually go beyond just the sort of representation part, but also can begin to be leveraged in order to solve some really complex design problems with you, okay? Okay, enough from me. I've talked long enough. I'm around for the next 10 minutes or so if you have any questions, or if you just want to continue to work and show off what you have. You can always share your screen.
Josh,
Or if you have any quick questions, I can troubleshoot, folks.
I
I'm
had a
going to go ahead and
quick
stop
question.
sharing my screen. Let's